The objective of this experiment is to determine the coefficient of static friction of different surfaces.
For frictional force experiment, the apparatus that we require in this experiment is a wooden block, but one side is covered with rubber. Then we need 15 grams of masses, 10 Newton spring scale, string, and tabletop.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. So today we're going to do the experiment 4. It's about the frictional force. So let's get started. How we going to start the experiment step by step, more easier with the picture and also with the video. Later on I will put after the end of my speech and also in my speech. So the first one, measure the mass of wooden block, record SM. Second, set up the apparatus as shown in figure 5.2. I will show you later. Number 3, make sure the tabletop is stable and horizontal to the ground. Number 4, attach the spring scale and the wooden block with the strings. Place them horizontal on the stable, the rubbery odd face downward. Number 5, place a 50 gram mass on the wooden block, mass on the block. And number 6, pull the spring slowly once the block start to move. Record the spring scale reading. Record the value of force and W in table 5.1. And number 7, repeat step 4 until 5 for 3 trials. Number 8, add another 50 gram mass on the wooden block and repeat step 5 to 6. Repeat the step until total of M is equal to 500 gram mass is on the wooden block. And number 9, repeat the step 1 until 8. This is time. Make sure the rubber side on the block facing upward. 500 gram W the data in table 5.2. So I will show you the video so you can do the experiment with clearly and smoothly.
Okay, now I would like to explain about the methodology of this experiment. Number 1, the measured wooden block mass has been recorded as M. Number 2, the apparatus has been prepared as shown, like this. Okay, the next one, number 3, the tabletop has been ensured to be horizontal to the ground. Number 4, the spring scale and the wooden block were attached with a rope and they has been placed horizontally on the tabletop. The rubber part of the wooden block has been ensured to be facing down. Number 5, 50 gram mass was placed on the wooden block. And the 6th step, the spring was slowly pulled. Once the block started to move, the spring scales reading recorded as Fs and tabulated. Number 7, step 4 until 5 for 3 trials has been repeated. And the last one, another 50 gram mass was added on the wooden block. Step 5 to 6 have been repeated until total for M equal to 500 gram mass was on the wooden block.
The sketch on the screen shows that the position of each apparatus on the experiment. The unit that being used in the experiment is Newton instead of centimeter because in this experiment we're trying to calculate frictional force that been applied on the wooden block plus rubber to the surface. And the next measurement units that we use is kilogram to calculate the mass of the slotted mass.
This is the result for this experiment. We have mass of wooden block with rubber surface, which is M, equal to 82.56, uncertainty with 0.005 gram. Table 1, rubber surface towards the floor. In the first column, we have mass equal to M. Next column, we have total mass, which is M, mass of the wooden block with rubber surface, plus weight mass. Next column, we have total weight, which is W. We calculate the weight by divide total mass with 1000 and multiply with 9.81 to get the total of weight. Next, we have static friction force, which is Fs. There's 3 trials, and we calculate the average by add all the trials result and divide by 3. Table 2, for non-rubber surface towards the floor. So, same as before, the first column is mass equal to M, and the second column total mass, which is M, mass of wooden block with rubber surface, plus weight mass. And then for the total weight, we calculate the W using the same method, which is total mass divided by 1000, then multiply with 9.81 to get the total weight. Next, for the static friction force, which is Fs, we do 3 trials and get the average result by divide all trials result and then divide by 3. So we get the average answer.
First analysis for this experiment is draw and level the free body diagram for the wooden block. Second, plot graph of static friction force against normal force for the rubber surface and non-rubber surface. Compare and discuss the coefficient of static friction obtained. The coefficient of static friction for rubber surface is 0.7206, while the coefficient of static friction for non-rubber surface is 0.3399. Based on the data obtained, the result shown that the coefficient of static friction for the rubber surface is higher than coefficient of static friction for non-rubber surface. The reason for the differences is the rough surfaces can produce large frictional forces. Therefore, the rougher the surface in contact, the greater the frictional force.
My name is Batrisha binti Abdul Aziz and my student ID is 2022-808942. Frictional force is the force generated by two surfaces that contact and slide against each other. In this experiment, the friction force between a wooden block and a rubber surface on a horizontal and inclined plane is measured. And from the plotted data, the coefficient of static friction is obtained. Static frictional force does not depend on the surface area of the contact between two objects. Instead, it depends on the surface characteristics of those objects, the masses of the two objects, and the force pushing them together, such as gravity forcing a car to press against the surface of the Earth. Current theory suggests that when rubber moves over a smooth surface, it is the molecular forces between the two that are the main cause of friction. Based on the results we got after running this experiment, a wooden block with rubber surface is quite difficult to drag across a surface because it has a high friction coefficient. A wooden block without a rubber surface is easier to drag across a surface because it has less friction coefficient. The results we obtained through this experiment supported our hypothesis. The larger the number of masses, the higher the static friction force. There may also be some errors in performing this experiment, such as inconsistencies in the surface, that is, the surface used is not uniform. The inconsistency of the surfaces will lead the different force readings depending on how rough or smooth the surface is. Furthermore, the deformation in the shape of the wooden block will affect the results of this lab. If this experiment were to be repeated, no changes would be made, but perhaps a few enhancements to ensure this experiment is conducted smoothly. This result contributes to existing research that frictional forces are mainly affected by the surface texture and the amount of force impelling them together. Therefore, what are the other types of friction?
The conclusion of this experiment is, based off this experiment, we can state that static friction is the friction that acts on an object that is at rest. The force can be found on the measurement in this experiment.